Go into the guided practice next, and we're just going to get some more practice with finding the power values, figuring out where the asymptote is, and how we graph exponentials. Now, I want you to go ahead and in that blue packet, draw a line after numbers 1 and 2, because take a look at the equations down below. Ew!
Yeah.
What is it?
Ew.
It's a log! What even is it, you know?
Well,
we're going to get into that a little bit.
A log is it's like a little stick.
Yeah, it's a giant stick. Has anybody taken chemistry in here? Are you guys doing acids and bases yet? Because you're going to encounter log as an operator there. So that's kind of one of the applications of logs. We're going to start logs today. It's going to be another way of rewriting exponential form. So more on that later. But yeah, we're only going to do these top two problems right now. So let's go ahead and look at these top few. And remember those steps that we outlined in the notes. Step 1. State the transformations and whether it's growth or decay. What's that 2 doing? This one, vertical stretch by 2. What's that 1/3 doing? That's the base, and it tells me that this is a decay function. What about that -2? Cross your eyes, does the opposite of what the sign should do. To the right, excellent. And if you get confused on whether it should go left, right, or up, down, when it's inside with the x is a horizontal movement, so that's how I remember that it's left and right, and I cross my eyes for those x's. And then -5, then it's going to move us down 5. So now the big question, moving on to step 2, where's the asymptote? It starts at y = 0, so thunk right here. And then we are going to see if any of these transformations do something to it. We vertically stretch it, nothing. The base, nothing. We move it right 2, same horizontal line. But if I slide it down 5, now we are in a new location at -5. You gotta draw in the asymptote, it's part of the graph. So y = -5. Beautiful. So now the tricky part. We want to try to make the exponent be equal to those power values. But because there's that -2 up there, I don't just get to plug in -1, 0, and 1. Instead, we have to think about what x values I can plug in to get me those power values. So we started with 1 last time. 0, I think, is actually the easiest one to start with. What can I plug in for x so that when I subtract 2, we get 0? 2. So we plug in 2 and we get 0. What can I plug in for x so that when I subtract 2, we get 1? What -2 is 1? 3. And then what -2 is -1? 1. So notice how these are all kind of within 1 unit of each other. So that's kind of a nice little check. So these are the x values we want to plug in to get these power values. And then it's PEMDAS time to figure out the outputs. So let's start with the first one, since it's the nastiest one. Actually, no, this one will be a little less nasty. So we plug in 1. 1 - 2 is -1. What's 1/3 of the -1? Reciprocalize it, and it becomes 3. 3 times 2 is 6, and 6 - 5 is 1. Try the next 2 on your own. You're plugging in this x value. It'll give you that power value, and then follow your rules of PEMDAS. What'd you get from plugging in 2? It's a nice number. It's not a fraction. -3. Wonderful. So to walk you guys through that, we plug in 2 for x. 2 minus 2 is 0. A third to the 0 is 1. Anything to the 0 power is 1. 1 times 2 is 2. And 2 minus 5 is -3. Now plugging in 3. 3 minus 2 is 1. A third to the first is a third. 2 times a third is 2/3. And 2/3 minus 5. And if you're like, I don't want to think about that, Miss Taro, you can use your calculator. So 2/3 minus 5, 2 divided by 3, is -4.3333333, which you can write it as -4.3, or you can write it as -4 1/3, or you could write it as -3. Don't care which way you want to write it because it's mainly the graph that we are trying to get. So I would like to see values here in this table, but it's okay if you get a rounded answer for those fraction decimal ones. So let's go ahead and plot these points. What's my first coordinate? -1, 1 or 1, 1? 1, 1. And then 2, -3. And 3, -4 1/3. Those are your XY coordinates. Do not accidentally use the power values. Why the emphasis, Miss Carol? Because I accidentally did that one time. Actually, a few times. So it is an easy mistake to make. So please make sure that you are using the XY values as your coordinates. So 1, 1. Boop. 2, -3. And then 3, -4 1/3. Where do you think we're going to level off towards the asymptote? The right or the left?
The left. The right.
The right. You're on the left. We're going down and then curving towards the asymptote. So this is our Red Bull function. We chug an energy drink. We're way up here with our energy and then crash down towards the asymptote. On your own, state the domain and range. Compare with a friend or an enemy or whoever is close by to you. What's our domain? Oh, real numbers. What? -infinity to infinity. So again, you don't have to write both, just one or the other. And then our range. We start at the asymptote, which is at -5, based on that vertical transformation of going down 5. So y is greater than -5, or -5 to infinity. All right, folks, here was what I would like you to do. On the next problem, state the transformations and figure out where the asymptote is. We have a couple minutes to try that. So transformations, asymptote, just the first 2 steps. This isn't a meme. This guy is going to be our mnemonic device that helps us remember what logs are and how they work. Hold the log. And this picture is on canvas. You're going to hear me be really obnoxious with this mnemonic device, so I hope you enjoy it. Folks, while you are staring at that elephant, let's talk transformations. That -3. How many things is that doing? 2 things. The negative is a vertical reflection. The 3 is a vertical stretch by 3. What about the 4.5? Is that greater than 1 or between 0 and 1? Greater than 1, so it is a decimal, but this is still a growth function because it's greater than 1. Doing on the inside, opposite of what you would think, left one. And then the plus 2, up 2. So where's the asymptote going to be? At y equals 2. Very good. This graph grid sucks. There we go. So y equals 2. How are we doing with those transformation steps in the asymptote? It might take a little bit of refreshing to remember those transformation rules, but you can use your calculator to check yourself. But the table takes a bit of savviness here. So we can't just plug in -1, 0, and 1 because of that plus 1 up with the x. So we need to figure out what can I plug in for x to get me those power values. Give it your best shot. I like to start with 0 first, and then the positive 1, and then the negative 1, but it's totally up to you. See if you can determine what you can plug in for x to make the exponent be equal to those values. What can I plug in for x so that I get -1 for the exponent? -2. What can I plug in for x so that the exponent is equal to 0? -1. So -1 plus 1 would give me 0. What can I plug in for x to give me 1? 0. Now for this one, I think I'm just going to use my calculator because PEMDAS is going to get a little bit messy with that decimal base. So go ahead and get out your calculators, and we're going to practice plugging this in. So we'll have little -3 times 4.5 raised to the older calculators. You are going to have to put this in parentheses. Or just straight up add the input and make it -1. So you could either do in parentheses -2 plus 1, or we can just write to the -1. And then plus 2. That gives me 1.3 repeating, or 1 1/3. Do you guys remember the shortcut for copy pasting on your calculator? Second, enter. Now I'm going to replace that -1 with a 0. And I get -1. Now we're going to replace it with 1. I get 11.5. Not great as far as points go. So remember, your coordinates are these. So -2 up 1 1/3, right about there. -1 down 1. And then 0, -11.5. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 5-ish. We'll say that. So, plummeting and leveling off towards the asymptote on that side. Domain is all real numbers. And the range, y is what than 2? Less than 2, or -∞ to 2. And that is graphing exponentials in a nutshell. So folks, in your homework packet, there are 4 example problems of this. So 1 through 4 are graphing exponentials. I'm going to give you 8 minutes to get some practice on those problems, and then we're going to start talking about the log and the elephant. 8 minutes on the clock. Go!